This chapter covers experimental and quasi-experimental research. First, I have a question for you. What is the goal for experimental research? Establish cause and effect relationships. In other words, an independent variable is manipulated to judge its effect on a dependent variable. It is difficult to accomplish, and requires rigorous research designed to eliminate rival hypotheses. Please note that cause and effect can be established only by the application of logical thinking to well-designed experiments, but not statistics. 3 criteria must be present to establish cause and effect. 1. The cause must precede the effect in time. 2. The cause and effect must be correlated with each other. 3. The correlation between cause and effect cannot be explained by another variable. Number of drowning and ice cream sales are highly related. As one goes up, so does the other. That does not mean that eating ice cream causes drowning, but rather a third variable relates to both of them, the temperature. The temperature goes up, so more people are in the water and the number of drowning increase. As the temperature increases, people eat more ice cream. Below are the steps in experimental research. State the research problem. Determine if experimental methods apply. Specify the independent variables. Specify the dependent variables. State the tentative hypotheses. Determine measures to be used. Pause to consider potential success. Identify intervening extraneous variables. Formal statement of research hypotheses. Design the experiment. Final estimate of potential success. Conduct the study as planned. Analyze the collected data. Prepare a research report. Cause and effect can be established only by the application of logical thinking to well-designed experiments. The application of this logic is made possible by the following. 1. The selection of a good theoretical framework. 2. The use of appropriate participants. 3. The application of an appropriate or sound design. 4. The proper selection and control of the independent variables. 5. The appropriate selection and measurement of the dependent measures. 6. The use of correct statistics model and analysis. 7. The correct interpretation of results. Validity of measurement indicates the degree to which a test or instrument measures what it purports to measure, or measure what it claims to measure. Internal validity is the validity of findings with the research study, where external validity refers to the degree to which the findings can be generalized to other settings/populations. Both are important in a study, but they are frequently at odds with one another in planning and designing a study. Internal validity is the degree to which extraneous variables have been controlled in an investigation. It is the validity of findings with the research study. The technical soundness of a study, particularly concerned with the control of extraneous influences that might affect the outcome. Our concerns with internal validity is, did in fact the experimental treatments make a difference in this specific instance? It also refers to the degree of confidence we have in the results of the experiment. In other words, is the treatment the only reasonable explanation for change in the dependent variable? Internal validity is considered the basic minimum for experimental research. Did, in fact, the experimental treatment X produce a change in the dependent variable Y? Possibility of other factors producing the change. To gain internal validity, the researcher attempts to control everything and eliminate possible extraneous influences, and lends itself to highly controlled, laboratory settings.